uh, which was enabling sorting through generic data. Pretty sure was what it was called. But yeah, 2.1 explanation. So good our vector, of course. There's a namespace, and then we go to our ascending integer comparer. So this compare function returns a negative number if a, well, if b is greater than a, 0 if it's equal, and then positive if a is greater than b. Yeah, and this overrides the default comparator in sort comparer. So yeah, I wrote down the sorting complexity, which was for ascending order, which was it's either big theta n log n, or big omega n log n, or big O n log n, which is I guess all standard in array sort. And we've got our descending integer comparer. Pretty simple. Sorts them in descending order. And the even number first comparer, which was the hardest part for me in this section, as we were trying to figure out if that we make the even numbers come before the odd numbers. Actually, W3 School has helped me a bit with this bit, which was fantastic. But overall, if both were even or both were odd, it falls back to the normal ascending comparison, because it won't change. But if it was even, if it was odd first before even, we needed to relegate that. So what we had to do with I'll just explain this a little bit more. So this checks the parity of each number, doesn't it? So the int mod a equals a percentage 2. It actually means if 0 if 0 is of a is even, and then if 1 of a is odd, and then I guess it's the same for mod b. So yeah, even number mod equals 0, and then odd number mod equals 1. And then, well, if mod is equal to a, it returns to the compare to, so as well. So that's your little, if they're both equal, or if they're both odd, or if they're both even. But if they're different, 0 or 1, then yeah, it'll go minus 0. Anyway, so if mod a equals 0, which would mean it's even, and then mod b is 1, which would be odd, it'd go mod a minus mod b, and that would equal -1, meaning it, a comes before b, or even comes before odd. And then if it was the other way around, so if mod a equaled 1, so mod a was odd and mod b was even, then a comes after b. I hope I said that, properly. But that was that took a lot of time to wrap my head around, but eventually got it. Eventually understood it. Let's continue with the rest of the program then. So finish the mod stuff. So we've got the student, class, and comparers now. So the student has two properties. You've got the name and the ID. Then it implements the comparer, comparable student vector. to allow like a default sorting by ID. Yeah. And then the toString gives a readable format. So it'll say like, okay, 5 Daniel or whatever, like where it is, the ID, element ID, and the location, and then the name, which is in that location. If that makes sense. Ascending ID comparer. So this explicit sorts students by increasing ID. Sorry, explicitly. So it only sorts, students by increasing ID. So this will be the order of the vector. So you've got Daniel at 0, Ben at 1, Cheyenne at 2. It'll show it in that order. So, yep. Sorry, it'll like sort them in that order. And then we've got the descending, which is the opposite, sets by descending name. So, and if the names are equal, it'll sort by the descending ID. So this one compares the names, and then, we'll do them in descending order. We've got our vector class, initialize data, initialize size. Started being the holding elements, of course, like how many, the backing array holding elements, you know what I mean? And then the size being the number of elements in the vector. Yeah, this is pretty similar to the previous one as well, because we've got our sorts here. Of course, actually we'll do the add first. Sorry. So yeah, as new items to the vector, and then if the internal array is full, it actually doubles the size here. So instead of doing like +1 to allow it to do it, say the capacity is 10, it'll actually double to 20, to allow for, I guess, more students if we need it. And the array resize, that behavior, it allocates a new array and then copies all the elements from the old one to the new one. And that array that has been like created is double the size. If that makes sense. So sweet. I also wrote down the time complexity of that from the way I understood it. Let me have a look. Where did I write it down? Over here. So the best case for that would have been big O in brackets 1, and then the average time would have been the same, but thank you to the, because of the doubling strategy, it would have been, I wrote down amortized as well. And then I guess the worst case, which was big O, and then it would have been big O, brackets N, and then because of resizing, like during it, it would have copied all the elements, if that makes sense. So we've got the sort, gotcha sort. So sorts the vector, using the default comparer. For the T for the vector. And in the best case, it'll nearly sort all like the small data set, and then the worst case will be like quite a heap of fallback. So sort fallback. So we go down to the index real quick. Just quickly summarize this. But this allows the array access to the vector. Array-like access. Doesn't actually access. It validates your boundaries and creates, the index. So, and then you got toString as well, which calls it. readable format for the user. So, hope that's all good. Thank you.